downloaded from the cloud. Okay. All right. So
It's
now let's,
recording.
yeah, I see. It says it's recording. Great. Okay. All right. Today we're going to continue with what we were talking about yesterday, where we started talking about working with monomials and polynomials, and we're how to combine by adding, subtracting, multiplying, and dividing of polynomials. So I'm going to start, this was just a review. I was doing this with some of the students. This was a system of equations. Before I actually start the material on polynomials again, I just want to make it clear. A few people asked me to reset their quiz. I will do that after class today. What I cannot do is once I've reset it, I cannot go back to the old one. So once I clear it, it's clear. I don't have any access to anything old. A reset means it's gone. It's like you never took it. You're going to have to, if you want it, you can ask me to reset it a couple of times. I'm perfectly happy with that. When I give you quizzes and assignments and tests that are my personal tests, I said this to people before, but I'm saying it because more people are on, and you want to retake it, I will always reset it for you without any penalty. You can always, if you're going to learn how to do something, and then you're going to be able to take a test. You weren't able to do it the first time, but you can do it the second time. That's what I want to see you doing. That to me means that you're advancing and you deserve the higher mark. You can do this.
Professor, I emailed you twice yesterday asking if you could reset the assignment, but you didn't get back to me.
No, I'm going to, any resetting, I didn't get a chance to do anything. Tuesdays and Thursdays, not only do I teach in the morning, I teach in the afternoon as well. So I usually don't get to do things. My days that I usually do things are Monday, Wednesday, and Friday afternoon. I did mention, and if you looked on the, if you read the whole email that I sent out, that I will reset it after class today.
Are
Okay,
you gonna
thank you.
reset everyone's or just specific people who asked?
Just the people who asked me to. If you
Okay.
didn't ask me to, I'm not resetting it, because why should I reset something if you didn't want it reset? So if
Oh,
you want me to,
Professor, did you grade them? Because I don't see like a grade for the quiz.
you should have gotten the grade immediately, because that's how it's set up. And when
On
did,
Delta Math?
yeah,
Yeah, well, I don't see like a grade or anything. It just says 100% done. That's all.
oh,
that's on the assignments, but on the quizzes, it should give you your grade.
Okay, I'm gonna go check now again.
Okay, if not, just send me an email. I can always, I have that, I'll see it and I can send you, but you really should be able to see it. I set up not only the homeworks, but I decided the quizzes, even though that isn't their standard way of doing a test. They like you to just not, give them the marks like a week later or something. I really want you to be able to, and you only have, and on their standard, their way of giving a test, they don't give you a second option, but I really thought it was important. If you try a problem and you got it wrong, that you should be able to try it again, because you might have just made a stupid mistake, and I'd like you to be able to have that option. So you should see right away whether you got that question right or wrong, right when you take.
No, it was not. I don't think it was that one. I think it was the one before that. I'm not sure. Let me check. Hold on.
Okay, I don't know. Check again. As I said, now since I think I'm going to extend the due date for quiz 2 until after the weekend. until Sunday night. On Monday, I will send you out an email with what I think your mark is up to this point. In addition, as I said, I'm going to be setting up a test for you on the first 3 chapters that will not be on Delta Math, it will be on Blackboard. It will be a multiple choice test. I think it'll be about 15 questions. I haven't finished writing it, so I'm not exactly sure, but something like 15 questions of the type of questions and the type of setup that you're going to see on your midterm and then on your final. Now, the midterm, this test, it's going to be a test. But if you don't do well on the test, I will allow you to take it again because it's my personal test. The midterm and the final, that's from the department. I can't give you an option to take it multiple times. The midterm will consist, unless they change it, and I don't think they will be 20 questions. The final is 30 questions. So I want you to have this test on Blackboard so you have experience taking those type of tests. I will probably give it to you, make it available either on Wednesday or Thursday of next week, and you will have to be finished with it sometime. I'll give you a due date, just like this, but I'm extending the due date on quiz 2 till Sunday evening. We are looking, after we finish the chapter that we're doing right now, this is a chapter on polynomials, we will be prepared for the midterm, which will be in approximately week 7 of the class. We're now finishing week 5, so in about 2 weeks, we should be up to midterm time. So I'm going to put on the board right now an example of something that we talked about yesterday. I'm going to let you work on it. And while you're working on it, I'm going to take attendance. So let's say I have this example. I want you to perform the indicated operation. I have 5x cubed y to the second times 3x squared minus 10xy plus 2, that's a plus, 2y squared. I would like you to, this is, if you recall, multiplication, where we have a monomial, this is a single term, times a trinomial, this is 3 terms. And if you can combine any like terms, I'd like you to do that. Okay, so while you're doing that example, I am going to take attendance. Zia?
Yes,
Yes. Good morning.
good morning.
Nashia? Nashia here? Nashia Allen? Anna Belkis? Anna Belkis, does anybody know what, she hasn't been here a few times. Somebody said they talked to her. Anybody have any idea of what's doing with Anna Belkis? Okay. Emma. Okay, Emma's not here either. Messiah, I saw you came in. Messiah, were you here yesterday?
No.
Oh, okay. I just don't want to make a mistake. April, I saw that you came in. So April's here. Khadija. Khadija here? Umar, I saw you come in. That's the advantage of having the waiting room. Yakima, Yakima, you had not been here yesterday?
No, I was not here yesterday.
Cheryl, I saw you come in. Stacia, I saw you come in. Natalie, I think you came in also. Pretty sure. Natalie?
Yeah, I'm here.
Yeah, I thought. Erica, I think I'm pretty sure I saw you come
Here.
in. Yeah, good. Jonathan, we've been
I'm
having
here.
conversation, so you're here.
Yeah, oh, sorry. By the way, I sent the email for the test.
Yeah,
So you
yeah.
said
On the test or on the
The quiz, I'm sorry.
not on the quiz, but on the extra credit. That's what I saw.
Yeah, no, and then that one, and as well as I just sent you an email regarding the test.
Okay. I'm after class. I'll go and I'll check all the emails and I'll take care of it. I'll try and deal with your question after class
Okay, that's fine.
or right towards the end of class.
Mhm.
Do you have that question written down?
No, I took a picture of it.
Okay, so if you'll be able to read it to me, so we'll talk about it.
Okay, no problem.
Okay, Luke Minot. Is Luke here? Layla. Okay, Layla, I know you're here.
Yes, I'm here. Professor, can you let me in? Because I'm trying to join from my laptop.
Yeah, and I don't see that. Oh, you have Melissa's
Yeah.
in charge now. Melissa?
Okay, thank you.
Okay.
I'm
It's a
in.
little slow on my end, but it's coming through. Just sorry.
Great, thank you. Ashley, I know you're here. Kachira, I think you're here, right? Kachira? I'm pretty sure I thought Kachira. Yeah, okay. Jennifer, I know you're here. Rachel Seeley. Gloria. This is very strange. I saw that she tried getting on. Does anybody know Gloria Villalba? Because she hasn't come to any of the classes, but she did try to get on to my Zoom class like yesterday in the afternoon. I don't understand that. Corey, I know you're here. Denisha, I think you're here, right?
I'm here, Professor, for
Here. And
the
Divine.
Y2. Is it a
Yes.
part of the 5x cube?
5x to the third, right?
So
5x3, y to the second, 3x to the second minus 10xy plus 2y to the second.
so I will have to multiply the 2y to the second
Yeah,
times 2y to the second, right? Okay, I know it wasn't bugging. Thank you.
okay, Stacya's well ahead of the game. I'm gonna ask Stacia, does anybody want more time on this? Okay, Stacia, do you wanna tell us how you did this?
Sure, I could try. I'm not sure if it's correct though.
Well,
Okay.
we'll tell you if it's wrong.
Okay.
We have no problem.
All right. So I used the 5 and I times it by multiplied by the 3, which gave me 15.
Correct.
I wrote my x and I add the 3 to the 2, which gives me 5.
Right. Remember,
There,
when you're multiplying and they're the same letter, the same base, you add their exponents. Perfect.
yeah. There's no y, so I wrote back the y2.
Right. Since there's nothing to, no y over here to, you just bring it down. Okay.
Yeah.
Now,
Then I have minus switch it. So 5 times 10, that's 50.
right?
I have a x there, so I wrote my x, yeah. And I add the 1x plus the 3, so I have 4x, yeah.
When something doesn't have any exponent, it's not
It's one.
a zero, it's a one exponent, right?
Yeah,
You
so I
get
have
an exponent of
4.
4, correct?
And the y plus the y, that gives me 3.
Right, because this is a 2 and this is a 1 is 3.
Yeah, give me 3. Plus 5 times 2, that's 10.
Correct,
I have no x, so I wrote back my x3.
right?
And I wrote back my y. And I add the y to the second and the y to the second, which give me y to the fourth.
Correct. Were you able to combine any like terms? Are there any like terms here?
No, there's not no.
No, even though they all have x's and y's, unless they have the same exponents on each of the letters, they're not like terms. The only thing that, when you're telling about like terms, things that can be combined, the only thing that can be different are the coefficients, the numbers in front. Is there anybody who has a question about this? Okay, so then let's go on to the next step. We started out adding, subtracting like terms. Then we started talking about multiplying of monomials. And then we went to multiplying a monomial, a single term, times a polynomial. So now we're going to go on to the next step, which is to multiply two polynomials. Let's see how we multiply two polynomials together. So let's say I had something that looks like 2x minus 5 times 3x plus 7. I want to multiply, and I know it's multiplication because I have these two parentheses right next to each other with nothing in between them. If there's no sign in between, that means that you're multiplying. If there had been a plus or a minus in between them, that would have meant to add or subtract. But when there's no sign in between, it means we're multiplying. And in this case, this is a binomial and this is a binomial. And we're going to multiply these two binomials. Now I'm going to show you a general method that will work for any polynomial times any polynomial. And then I'm going to come back and show you a method that is used specifically when we're multiplying just binomials. Because of most cases, the most common type of question we're going to have will be multiplying two binomials. But let's just talk about the general rule of multiplying polynomials. Let's say I want to multiply this 2x minus 5 times the 3x plus 7. What I'm going to do is I'm going to look at my first polynomial, which is the 2x minus 5, and take the first term in that polynomial. Now, the first term in this one is 2x. What I'm going to do is I'm going to multiply the 2x by the 3x plus 7. I'm going to use the distributive property to multiply 2x times the 3x and the 2x times the 7. So multiplying 2x times 3x gives me 6x to the second, because both of these have exponents of 1. And multiplying the 2x times the 7 gives me 14x. Because this one has an x, but this doesn't, so I just bring the x across. If there was another term in this polynomial, I'd multiply the 2x by it. In other words, it doesn't matter how many terms there are. take your first term and multiply it by every single term in that second one. Once you finish that, which we did, we multiplied the 2x by everything over here, go back to your first polynomial and take the second term, which is a -5. Don't forget the negative is part of the expression. Take the -5 and use the distributive property to multiply everything, the 3x plus 7 by that. So I'll do -5 times 3x, which will give me -15x, and -5 times 7, which will give me -35. If you notice, this was 2 terms, this was 2 terms. I ended up with a total of 4 multiplications, 2 times 2. Now I look at my final expression, and I see that there are some like terms. Usually the like terms are the ones that are in the middle. The 14x and the -15x are like terms because they have the exact same letter with the same exponent. The only thing that's different is that this is a +14 and this is a -15. Well, 14 and -15 gives me -1 or -x. The 6x squared I leave alone. The -35 I leave alone. And my final answer comes out to be 6x squared minus x minus 35. It turns out that we got a trinomial, 3 terms, out of multiplying the two binomials.
Would you be able to also use a Punnett square?
I'm going to use a FOIL system in a second, but I just
sorry.
want to show you that this method, I'm going to come back to this. I'm going to show you something called the FOIL system. For those of you who've already heard it, you'll know what I'm talking about. If you haven't, you'll know what I'm talking about afterwards. Let's now take a different problem. It's a little bit harder. I'm going to do this one with you, and then I'm going to give you one to try. And then I'm going to talk about something called the FOIL system. But let's first try something else. Can I erase this? I'm going to just leave it on the board that it was 2x minus 5 times 3x plus 7. I'm just writing the problem that we had, and the answer we got was 6x squared minus x minus 30. Okay. What if I gave you something that looks like this? Um, 3x minus 1 times 4x squared plus
¿En qué supermercado tú estás?
minus 3. Yes, question?
Claro, yo te necesito limón, tú. No hay limón para la vaina esa, para la desgracia que yo hago. Yo no soy abogado. Está bien, yo voy y compro ahorita entonces, cuando yo vaya a hacerme la soña.
I'm muting everybody. Also. Okay. All right. Now, what if I gave you, now notice what I have here, the 3x minus 1 is again a binomial, but the 4x squared plus 10x minus 3 is a trinomial. It's, again, I'm multiplying 2 polynomials, in this case, not a binomial times a binomial, but a binomial times a trinomial. But the method is going to be the same. I'm going to start with the first term in the first parentheses, the 3x, and multiply everything in my second parentheses by the 3x. I'm going to distribute the 3x to everything. Once I finish that, I'll go back to my second term, which is the -1, and multiply everything in the second parentheses by -1. And after I've done all that, I'll have 2 terms times 3 terms will give me 6 different things that I've multiplied. I'll look to see if any of the terms are like terms so that they could be combined. So taking the 3x times the 4x squared, the 3 times the 4 is 12. The x times the x squared. Well, this is an exponent of 1. This is an exponent of 2. Together gives me an exponent of 3, 12x to the third. Now I take the 3x and multiply by the 10x. So the 3 times the 10 gives me positive 30. And the x times the x gives me x squared. They each have an exponent of 1, but we don't write it in, but it's there. So exponent of 1 plus 1 is 2. So this gives me 30x squared. And finally, I take the 3x and multiply by the negative 3. So the 3 times the negative 3 is negative 9. And I just bring the x across. I multiplied everything in my second parentheses by the 3x. So now I go back and I start all over multiplying everything by the negative 1. The negative 1 times the 4x squared will give me negative 4x squared. Negative 1 times 10x will give me negative 10x. And negative 1 times negative 3, don't forget a negative times a negative is positive, so that gives me positive 3. If you notice, I have 1, 2, 3, 4, 5, 6 terms because I multiplied 2 terms times 3. 2 times 3 is 6. Now I go back and I see if there are any like terms. So my first thing is 12, and I'm going to arrange my term in what we call descending order. Highest power, then next highest power, etc. So the 12x cubed, there's no other term that has a 3 exponent, nothing to combine it. I just bring it down. I get 12x to the third. The next thing I see is a 30x squared. Well, there is another x squared term. There's a negative 4x squared. These are like terms because they both have the same x squared. So I combine the positive 30 and the negative 4. 30 minus 4 is 26. It's positive 26x squared. Now, my next term I see is negative 9x. Is there anything that looks like a term to the 9x? And yes, there's a negative 10x. These are both just plain x's. A negative 9 combined with a negative 10, negative 9 and negative 10 is negative 19. So that gives me negative 19x. And finally, there's that positive 3 that's just a standalone of what we call a constant. It doesn't have any x's with it. It's only one term. So here's my answer in the simplest form, everything combined. Does anybody have a question about how I did this? Any questions? So are we ready to try one on our own? You okay? I don't hear any response.
Yes.
Yes.
Okay.
Yes.
Can I erase this?
Yes.
Okay. Is there anybody who wants me to leave it on a little bit? Okay. So here's the next question. This is for you to try. Two y plus 4 times 3y squared minus 4y plus 5. Okay, I'm going to give you a couple minutes to try that on your own. Luke, when I took attendance, you weren't here. I just want to ask you, were you here yesterday?
Yeah.
You were here yesterday as well, okay. So I had you absent for both of those days. Okay, I'm changing that. All right, is there anybody ready? Okay, nobody's,
Wait, 1 second, 1 second.
okay. I'm waiting. Okay, Jennifer has said she's gonna try to get the answer for us. So,
Try.
try, that's the best thing that you could do is try, okay?
All right. So I started off 2y times 3y gave me 6y to the third.
Okay. Notice she got y to the third because this was a plain y, which had an exponent of 1, and this was a y squared, a y to the 2. So she added the 1 and the 2, and she got 3. That's perfect. So far, you're batting 100.
Then I did
1,000, right? And not 100, 1,000.
2y times -4. That gave me -8y squared.
Okay. Why did you call, why is it y squared?
Because it's y and y is 2. 1 y right here and 1 y right here.
There's a 1 here and a 1 here, those invisible ones.
Yeah.
Okay.
And then I did 2 times 5. It gave me 10y.
Perfect.
Then you go on to the 4.
Right.
And then it's 4 times 3y squared gave me 12y squared.
Correct.
4 times 4y gave me -16y.
Correct.
And then it's plus 20.
Right, because the 4 times 5 gave you 20.
Then you combine then you go down, it's 6y to the third. And then you do -8y plus 12y.
Y squared. Okay, so these are your like terms because they both have y squared. So what did you get?
4y squared
4y squared, right? 4y to the 2.
minus, and then you did +10 and -16y. That gave me -6y
Correct.
plus 20.
That is perfect. Any question about that? So that is multiplying this was a binomial times a trinomial. Now notice you could use this method. What if I gave you 10 terms here and 10 terms here? It would take you forever to do. It would be a very long problem, but it would be multiply everything by the first, go back, multiply everything by the second, etc. Let's go back to this and talk about something that I call the FOIL method. When we had this 2x minus 5y times 3x plus 7, we had done the same thing. We took out the 2x and multiplied it by the 3x and then by the 7. Then we went back. We took the -5 and multiplied by the 3x, and then we multiplied by the 7. And the final answer we got was 6x squared minus x minus 35. So the question is, what is the FOIL method? What does it stand for? It's just what we call a mnemonic device, a reminder. A mnemonic device is something to remind you that this is what you have to do. Because you're going to see, actually what we did was actually FOIL. FOIL stands for first, outer, inner, last. When you have two binomials, two terms times two terms, you'll have to do 4 multiplications. Now you really know this. This is just saying what we did before. You have to first multiply the first terms. Well, which are the first terms? The 2x and the 3x. The things that come out first in each parentheses. 2x plus 3x gives you 6x squared. Then you do something called the outer. Outer. Those are things that are far apart. What are the outer terms? Well, the very first one times the very last one. Those are the outer. It's the 2x times the 7, or the 14x. Notice that's what we had done when we did this distributive. 2x times 3x and 2x times 7. Inner. Inner means the things that are closest together. What are the things that are closest together? The ones that are sort of attached without any sign in between them is the -5 and the 3x. The inner is -5 times 3x, which is -15x. And the last stands for the 2 last terms in each parentheses, -5 times 7, which is -35. Now notice, this is exactly what we did. We did 2x times 3x and 2x times 7. Then we went back and we did -5 times 3x and -5 times 7. This is just a reminder of what you're doing. Now notice, again, you're going to have to combine the like terms. Usually your like terms are the outer and the inner. The 14x and the -15x give you -x, so that your final answer comes out to be 6x squared minus x minus 35. Notice it's basically exactly what we did before. It's just giving it a name. Now, FOIL stands for first, outer, inner, last. It means the method you use when you're multiplying one binomial times another. Now, sometimes you have something that looks like this. What if I gave you this problem? 3x plus 2y squared. What if I gave you a binomial with a exponent on the outside? Really, it's nothing new. You just have to remember, when you have a binomial squared, you just have to rewrite the problem as 3x plus 2y times 3x plus 2y. The exponent of 2 is telling you that you're multiplying the binomial twice. And you have to write it out twice, and then you can do either the distributive method or the FOIL method. See if you can get the answer to this using the FOIL method. Anybody want to help me out with this one?
I can.
Okay, is that you, Jonathan?
Yes.
Okay. You have to talk loud because your mic is not that strong.
Oh, okay. I said, I just did for me personally, I do a permanent square. Like I do 4 squares, but I can just do the 4 method. So 3x out the first be 3x and 3x. I got 9x squared. The outer, I got 6xy. I'm mistaken.
Right, she did the 3x times the 2y, so that gave me 6xy.
Yeah. And then the inner, I got 6xy as well.
Right, because the 2y times the 3x is 6xy.
And the outer, the last, and I got 4y squared.
Right. Let me just interrupt. He did 2y times 2y, that gave him 4y squared. If you notice, since it is a binomial squared, we're multiplying a binomial by itself. The inner and the outer always turn out to be the same when you're squaring that. Okay, keep going.
And then I combine like terms, and then I got 9x squared plus 12xy.
Right, these are the like terms, so that's 12xy.
Plus 4y squared.
Perfect. Excellent. Any question about that? Okay. So don't forget, whenever you have a polynomial and you want to square it, you have to rewrite it. So you're writing the parentheses twice, and then you just use regular, in this case, just FOIL or just the distributive property, but you must write it twice. Don't think you just have to square the 3x and the 3y. You have to actually multiply using 2 terms times 2 terms. Okay, what if I gave you something like this? What if I gave you 5x minus 2 times 5x plus 2? If you look at these two binomials, they look almost identical. They both have 5x's, they both have 2's. But one has a negative between the 2 terms, and one has a plus between the 2 terms. Those type of binomials are what we call conjugate binomials. I don't know why they're called conjugate binomials. I know what the word conjugate means, or conjugate, but I don't know why it's called conjugate binomials, but that's a term that's used. Something very interesting happens when you multiply conjugate binomials. Again, they're binomials, they're not identical because one has a plus and one has a minus, but they're almost identical. When I use FOIL on this, let's see what happens. I'll do 5x times 5x, that's first, which will give me 25x squared. Then I'll do FOIL, outer. So I'll do the 5x times the 2 furthest ones away, which is the 10x. Then I'll do inner, the 2 closest together, which is the -2 and the 5x, which is minus 10x. And finally, L is last, -2 times +2, which is -4. And what happens when I go to combine the like terms, I see the inner and the outer, the 2 middle terms, are actually the same number, but one is positive and one is negative. Well, what happens when I combine 10x minus 10x? I get no x's, 0. This just cancels out. So that my final answer becomes 25x squared minus 4. We're used to, when we multiply two binomials, that the final answer turns out to be a trinomial, 3 terms. It happened over here, it happened over here, but here it didn't. And this is something that will always happen when you have conjugate binomials. When you have conjugate binomials and you do the FOIL, the outer and the inner will be the exact same number, but one will be a positive and one will be a negative, so they'll cancel out. Why am I mentioning this? Because when I'll see that I have conjugate binomials, I'll know I can do a quick multiplication. I can just do the 5x times the 5x and get the 25x squared, and the negative 2 times the positive 2 and get the negative 4. I can forget about the outer and the inner because I know they're going to cancel out. Now, I'm always looking for shortcuts, things to make life simpler. But we have to remember, we can only use a shortcut if it's conjugate binomials. Okay, let's see if you can do this. Suppose I give you 2x minus 7y times 2x plus 7y. Let's say I ask you to multiply those two together. And you should be able to do it very quickly. Anybody want to tell me what they got?
Professor, is that 2x plus 7y for the second one?
Yes. When I stretch, I don't always get the looking too well.
It wouldn't be 4x squared minus 56? Minus 40, ooh, 49.
Close, minus 49 what?
49y.
Y. Just
Squared.
Y?
Minus 49y squared.
Right. These are again conjugates. That was you, Jonathan, right? Thank you.
Yes.
I'm beginning to recognize people's voices because it doesn't, unless I have it set, it doesn't tell me who's.
When you hear high-pitched voice, remember it's me.
Also, you speak very gently.
I do.
That's why I sometimes tell you to speak louder because I know that not everybody's mic. I'm teaching here in the house and I'll come downstairs and my husband will tell me, why were you screaming? But I really try to talk at the top of my lungs so that everybody can hear me. I hope you can hear me well.
Yeah.
Okay, looking at the 2x minus 7y and the 2x plus 7y, obviously these are conjugates. They're the identical binomials, but one has a minus and one has a plus. So I don't have to do the whole FOIL. I can do the quick way. I can just do the first, the 2x times the 2x, which is the 4x squared. And the negative 7y times the positive 7y, which is minus 49y squared. Again, when we multiply two conjugate binomials, instead of getting a trinomial as an answer, we get a binomial. That middle term has been canceled out. Now, of course, if you did it the long way, the whole FOIL way, you'd get the right answer. But it's nice when you can do things quicker. And it helps us in what we're going to be talking about next, which is something called factoring. I'm going to leave this problem on the board, but I want to talk about what the rest of this chapter basically is about. It's about something called factoring. You would have thought that if I'm doing a chapter on polynomials where I started out with adding, then I did subtracting, now I'm doing multiplying, what would you expect the next thing to do? I would have thought the next thing on the chapter should be division. but it's not. Happens to have division in the book, but it's in the next chapter. The last part of this chapter is something called factoring. Now, you probably know factoring as something that you do with numbers. For example, I'm just going to illustrate what factoring is with regular numbers. Let's say I have something like the number 35. And I want to find what are called the factors of 35. What I'm looking for is what numbers do I multiply together to get 35? In other words, factoring is a little bit of undoing of multiplication. I have my answer 35. What would the numbers did I have originally that I multiplied that gave me the 35? And I think everybody knows that the answer would be 5 times 7. The factors of 35 are 5 and 7. And it's not exactly division, but it really is. You are dividing the numbers up. And once you know one of the numbers, let's say you know that 5 is one of the factors, you could figure out what the other factor is. If I tell you, oh, I know the factor of 35, you don't know this. I know the factor of 35, one factor is 5. I could go to my calculator and do 35 divided by 5, and then it would give me the 7. So in a little bit, it is a sort of division, but you're never going to get decimals or anything like that, which you sometimes get. If I divide 37 by 5, I'm not going to get an exact number. When we're doing factoring, we're looking for exact numbers that multiply to get this answer. Well, we're going to be doing factoring on polynomials. And if I'm factoring in polynomials, what I'm looking for is what were the original polynomials that we multiplied in order to get this final answer. In other words, I'm starting with the answer and looking what was the question. Just like if I started with the 35 and I asked, oh, what did I multiply? It started, instead of starting with the 5 and 7 and getting to 35, I'm starting with the 35, sort of working things backwards. That's what factoring is about. Now, when it comes to an expression that is a binomial, two terms, where the first is a perfect square, what do I mean that the first is a perfect square? It means that I can tell you what two things I multiplied that are exactly the same that gave me this number. 4x squared is what we call a perfect square because it's equal to 2x times 2x. The second term in this binomial also has to be a perfect square. And it is, in this case, because 49y squared is really 7y times 7y. So the first term has to be a perfect square. The second term has to be a perfect square. And the sign in between them has to be a minus. It's called the difference
Professor.
Yes. I'm listening. Yes.
Oh, I'm sorry. I was just fixing my mic and it worked.
Okay.
It's because she was speaking.
Okay, good. Oh, that's great. I'm glad you can speak now. Okay. So, as I said, this expression, this binomial is called the difference of Sometimes it's called the difference of squares. Sometimes it's called the difference of perfect squares. I'm just going to call it the difference of squares. Whenever you have a binomial that is the difference of squares, then you could factor it immediately into two binomials that are conjugate binomials. You take the square root of the first term, the 4x squared would give you 2x and 2x. You take the square root of the second term, which is of 49y squared, which is 7y and 7y. And you put a plus in the one parentheses and a minus in the other, so that you get conjugate binomials, because we know when multiply conjugate binomials, we only get a binomial where the first is a perfect square and the second perfect square, and there's a minus in between them. So if I see that setup, this is just a matter of observing and remembering this factoring of the difference of squares. Let me give you another problem. Suppose I had given you this. 64x squared minus 25. And I look at that. Is it the difference of squares? Yes or no? Anybody? Is this the difference of two perfect squares?
Yeah, it's a perfect square.
Right. Both of you, Cheryl said yes also. If it's the difference of squares, then I can right away factor it into two parentheses. What's the square root of the 64x squared?
8
8.
times
8x, right? So I put an 8x in both parentheses. What's the square root of 25?
5.
5.
So I put a 5 here and a 5 here. And in one parenthesis, I put a plus in one parenthesis.
And 1 in negative.
And if you wanted to prove it, you could just multiply these together and you will see that that's what you get. This is the first example that we're doing, first type of factoring of polynomials. It's a very specific case. We have to have a first term being a perfect square, the second term being a perfect square. There can only be two terms. Can't be three terms, only two terms. Both the first and the second have to be a perfect square. And the sign in between them has to be a minus, because if it's a plus, this won't work, because the only reason it works is because a plus 5 times a negative 5 gives us a negative 25. So you need the difference of squares. I'm going to give you one more to try, and then I'm going to do one other type of factoring. That I wanted to, let's see if you can factor this. Nine x squared minus 121 y squared. See if you can factor this.
Could I try, Professor?
Okay, who is that?
Stacia.
Okay, Stacia, okay. You're our girl for the day. Okay. What should I do?
Okay. So at first I found the square root of 9, which is 3. So I have 3x and 1, 3x and that,
Okay,
yeah.
you didn't tell me, but I have to write the two parentheses, right?
Yeah, the parentheses, yes. And I have 3x in the other parentheses. Okay, then I have plus. The square root of 121 is 11, so I have 11y. And on the other side now I have negative 11y.
Perfect. And if you had written the 3x minus 11y first, and the 3x plus 11y second, in other words, you had the exact same answer except the different order, that would be perfectly okay. The order does not count in how you write these answers. Does anybody have a question about this? Okay, I see, excellent. I see the answers that I got on the chat were right also. So I would actually, usually I don't do this type of factoring first. It just seems to flow since we talked about how to multiply that we could go back and do the factoring. Now I'm going to talk about a different type of factoring. Okay, I'm going to erase this. And it's the type of factoring that has a tendency, people forget about doing it, but it happens to be the first type of factoring that you always want to do when you're told factor an expression. And that's what's called factoring a common monomial factor. So let's look at an expression like this. (10x squared minus 15xy plus 30xy to the third. I have a trinomial here, and I want to, question is going to be find the factors or just factor. And the first thing I'm going to do is try to find a number, and then I'll try and find a letter that will divide evenly into each term. So I look at my terms and just look at the coefficients, the numbers. Here's a 10, here's a 15, here's a 30. What number is a common factor of those three numbers?
5.
What?
5.
Right, very good. 5, because 5 divides evenly into each of them. That's what a common factor means. It goes evenly into each of them. And we always are looking for the greatest common monomial factor. It happens to be the biggest one we can find. 5 is the biggest number. Put that number down. Then you go to the letters, and you're going to deal with each letter separately. The first letter I see is an x squared. So I look at each term. This has an x squared, this has an x, and this has an x. They all have x terms in them. X is a common factor, but I always want the greatest one, so I want to know what is the largest. What exponent can I use on the x? That's the largest I can use that will go into each term. And that's really very easy to figure out because you always look at all the terms and see what's your smallest exponent. This has an exponent of 2. This x has an exponent of 1. This has an exponent of 1. So therefore, the common factor
Is it
of
1?
x's is just x to the 1 or x.
Oh, good.
Then I go to the y's. Oh, is there a common factor of y? My first term doesn't have any y. It doesn't matter if the others do. In order to be a common factor, it has to be in every single term. So I look, when I'm looking at the letters, I look at every single term has to have the same letter. And if they aren't all the same exponent, then just pick the lowest exponent. It turns out the greatest common monomial factor that I can find is 5x. In other words, 5x is one of the expressions that I multiply by to get this answer. It's like I took my 35 before and I said, oh, one of the factors was 5. What's the other factor? Well, if one factor was 5, I divided the 35 by 5 to get the 7. So we have to find the second factor. What did we multiply the 5x by to get this thing? And the way we do that is we take each term and divide it by this 5x. So you see how factoring really uses a little bit of division. How do I divide? When I first divide the numbers, the coefficients, 5 into 10 gives me 2. I know it's going to come out even because I picked numbers that would go in evenly. And when I divide the letters, remember for multiplication, I'm adding exponents. So for division, I'm subtracting. So this is an exponent of 2. This is an exponent of 1. 2 minus 1 is 1. So I get x to the 1, or just plain x. And it makes sense because if I multiply the 5x times the 2x, it would give me the 10x.
Okay, 10 to the second.
Then I go to the second term and do the same thing. I divide the 5 into the negative 15 to give me negative 3. The x into the x. Now, when they have exactly the same, they're both exponents of 1, they just cancel out. So the x's are canceling out, but I'm left with a y. So this becomes negative 3y. And finally, I go back and do the same thing. It's almost like the reverse of distributive property. I'm dividing everything by this 5x. So 5 into 30 is 6. X into x, oh, that cancels out again because they have the same exponent. They're both exponents of 1. In other words, if you do 1 minus 1, your exponent is 0. It means it's canceled out. Now, if every single thing is canceled out, you have to put a 1. You can't just put a 0 because canceling out by division gives you an answer of 1. So here the x's cancel out, but the y cubes didn't, so I just bring down the y to the third. And here is what's called factoring out the greatest common factor. Is there any questions about this?
Yes, Professor. It's
Yeah.
it's a 2x in a parentheses because it was squared at the top.
No, because remember, this was a 5x, which had understood to be a 1. If I take the 2 minus 1, this will give me a 1 exponent. So it should be a 1 exponent. We usually don't put in those ones because x times x. If you put an x squared here, then you'd have an x times an x squared, and this would have been an x to the third. Is that clear?
Yes, thank you.
Okay. Let's try another example.
Yeah, I need one more example to grasp it.
Okay. Let me see if I can find a nice one in my book. So I'm going to erase this and do another example. I'm going to let you try it. I'm going to give you a nice hard one. Six x4 y2 plus 18 x3 y3 plus 24 x2 y4. Okay, I'm going to give you a couple minutes to try that, and then we'll do it together. All right, I think we should try this together now. I first look at the numbers, the coefficients. There's a 6, an 18, and a 24. So the largest numbers that goes into all three of those, because there are three terms there, I have to go into all three of them, is the 6. So I put down the 6. Then I start looking at the letters. First, I'm looking at the x's. This x has a 4th exponent. This has a 3 exponent. This has a 2 exponent. Remember what I told you to do. Take the one with the lowest exponent. So that would be x2. Then I go to the y's. This has an exponent of 2. This has an exponent of 3. This has an exponent of 4. So they all have y's in them. So I take the lowest one, which is y2. Notice, if there were more letters, I would have gone through those letters. The hard part really is the coefficient, because the letter parts, you just look and you just take the lowest exponent that you find. All right, so we found the common monomial factor. We now have to find the polynomial that when I multiply it by this would give me this answer, which means I have to divide the 6x squared y squared into each term. So I divide the 6 into the 6, that cancels out. The x squared into the x fourth, okay, I remember when they don't have the same exponent, they don't cancel out. I have to subtract the exponent. So I have to subtract this 4 exponent minus the 2 exponent. 4 minus 2 is 2. That gives me x2. And then I do y2 into y2. Those have the same, they cancel out. Once they have the exact same exponent, they cancel out. Hint, if this would have been x squared also, so that this was identical to this, everything canceled out, you would have to put a 1. Do not just drop it, you have to put a 1, okay? We took care of the first term. Now we go to the second term. The 6 divides into the 18 and it gives me 3. The x squared into the x cubed. So 3 minus 2 is 1. So it's x to the 1, which I can just write as plain x. The y2 into the y3, again, 3 minus 2 again is 1. So this is just a plain y. So the second term is 3xy. And finally, the 6 into the 24 is 4. The x squared into the x squared. Remember, when they have the exact same exponent and you get 0, when you subtract, you just drop it. The only thing is, if everything gets dropped, then you have to put a 1 there. But so far we have a 4, so we're okay. Then we have a y squared into y4. 4 minus 2 is 2, so this gives me 4y squared. And this would be my answer in factored form. I have taken out the greatest common factor, 6x squared minus 6x squared y squared. And if you wanted to check it, all you'd have to do is multiply this monomial by this polynomial, and it should give you back to the regular answer. Okay. Does anybody have any questions before I say that this is where I'm leaving it? We're going to be doing more types of factoring on Tuesday. So far, we've done 2 types of factoring: the common factor and the difference of squares. We'll review that and then we'll go on with some new material on Tuesday. Again, I'm giving you until, I'm going to go back and I'm going to change it right now. As soon as I go downstairs, I'm going to reset those people who asked me to reset their quizzes or anything else that you wanted me to reset. Just as you said, send me an email and I will take care of that after class today. And I am going to extend the due date on the quiz number 2 to Sunday evening.
Professor, what's the name of this that we just did right now?
This is
Because I labeled them.
factoring.
This is the factoring, but it's just factoring of what?
Greatest common monomial factor.
Okay.
Or greatest common factor. Sometimes we don't even use this term monomial. Okay. Now I'm going to stay on for a few minutes to answer Jonathan's question. Anybody else who's interested can answer me, can listen. And then Melissa, you're going to be having a class today?
It depends on if anyone wants to stay.
Is anybody interested in staying for Melissa's class?
Yeah.
Oh, okay. Cheryl said yes. Okay. So you're going to have a couple of people there. Okay. But I just want to, Jonathan, you still there?
Yes.
Okay. So I want to, you're going to read me that problem and okay. What I probably will do is I'll give you a homework also on this chapter, just what we've done on the chapter, the multiplying and the adding and subtracting and dividing, adding, subtracting, and multiplying of monomials and polynomials. So look out for that. And again, make sure you finish up the quiz. And as I said, the midterm will be what we cover through the end of this chapter. Okay, Jonathan.
Yes, so this was a question that was on the it was labeled homework, but it's also said optional extra credit. So I
Right.
was doing it, And there was a question that read basically, it says at a particular restaurant, each onion ring has 40 calories, and each mini hot dog
Onion
has
rings have 40 calories.
and each mini hot dog has 80 calories.
Okay, so I'm gonna call it HD. It has how
Mhm.
many?
80.
80.
Mhm.
Okay.
And it says a combination meal with onion and mini hot dogs has a total of 19 onion rings, and mini
19
hot dogs
rings. Okay.
altogether and contains one
Okay, so
1,000.
it's not 19 onion rings, but it's 19 onion rings and hot dogs, right? All together.
Yes,
Oh boy, somebody's
and
really
contains
eating away there.
yeah, and it
And
contains 1,080 calories.
1080.
Yes, and it says write a system of equations that could be used to determine the onion rings in the combination meal and the number of mini hot dogs in the combination meal. Define the variables that you use to write the system. This was the only problem I didn't try because the wording was confusing.
Okay, I think that whole thing is just a lot of words.
Yes.
It's a lot of words, that combination meal. Take out
Yeah.
the word combination, and I think it'll
Oh,
be easier to understand. Here's what they're
okay.
saying. Somebody has ordered 19 things.
Yes.
Some of them were onion rings and some of them were mini hot dogs. And he got
Yes.
19 altogether.
Mm-hmm.
And the total number of calories that meal is, wow, is that's enough for a whole day for sure. 1,080 calories. And they want to know how many individual onion rings and how many individual hot dogs there are, these mini hot dogs. So should we call X the number of onion rings?
Yes.
And let's call Y the number of mini hot dogs that we have.
Mm-hmm.
I'm calling HG, it's HD. Okay. I knew I'm not an English teacher for a good reason. Okay. So let's see. What do we know about X and Y together? How much does X and Y together give it?
That was the thing. X plus Y equals, it wouldn't be 1080.
No, because when I'm telling you about how many onion rings and how many hot dogs, we're not talking about how many calories there are. We're just talking about how many there are. It has nothing to do with calories.
X plus Y equals 19 then.
Right. So my first equation becomes X plus Y equals 19. Now we have to include, for our next equation, we have to include the calories. That's like when we included the money with the other ones.
Yeah.
How many calories are we going to have on onion rings?
40.
40 for each one. And how many do I have? I have X of them. Let's say X is 10.
Okay.
So then
So
I would
40.
have to do the 40 times the 10, right? In
Mhm.
other words, I have to do 40x to get the total number of calories in the onion rings.
Mm.
And how many calories are there total in the hot dogs?
Plus 80Y.
Right.
Okay. Oh,
That's
okay.
gonna equal how much?
1080.
Right.
Oh, I was confused because there's a lot of words in there.
It's the wording. As I get the ones that I did in class, that's why I made this optional, because it is the wording, and it's always the wording that ends up causing difficulty. It's
Okay.
translating English to algebra. And it's just a matter of you get used to it.
Yeah.
Okay. Anybody have any questions they want to ask me? If not, I'm gonna leave. Melissa in charge. Okay.
Professor, is that the final answer?
This is they just asked for the equations, right?
Yes.
They didn't even ask you to solve it. If you wanted to solve it, of course, you probably would have.
They just asked for the system of equations.
Right. They just asked you to write so this would have been the final answer. Did they tell you did they care what letters you used? Did they say?
No.
No, okay.
No.
Okay, Melissa?
Professor,
Yeah,
I need help with one question.
sure. Who is that?
This is Kashira speaking.
Okay. Can I erase this?
Yeah.
Okay, do you want me to help you or you want Melissa to help you?
You can help.
What?
You can help.
Okay, I'll help you. Okay, what's your question?
The lines represented by the equations y minus 3 over 4x equals 7 and 3y minus 4x equals 27. How would I solve that?
What was the question about it?
It asks if it's in the same line, if it's perpendicular, parallel, or neither. Like, I want to know how would I solve it.
Okay. So what you want to do is anytime they ask you are lines parallel or perpendicular, or are they the same lines? In other words, they're asking you, is the system of equations a consistent or inconsistent or independent or dependent? Remember, we use those terms. But what we want to do with each of these is put them in the y equals mx plus b form. We want to put them in this what's called the slope-intercept form. So let's try number one. What should I do to get this in the slope-intercept form? That means get the y by itself. Well, if I want to get the y by itself, what I have to do is get rid of this 3/4 x, right? Does that make sense, Kishira?
Yeah.
So that first equation in y equals mx plus b form is y equals 3 over 4x plus 7. And in terms of the two important numbers that we talk about, the slope, the m is how much? What's the slope of this line?
3 over 4.
Right. And what is the y-intercept? That's what we call the b. What is the y-intercept?
Positive 7.
Okay, now let's go to number 2. I have to put that in y equals mx plus b form as well. So here is my 3y minus 4x equals 27. And I want to get that with a y alone. So what should I do with that?
Subtract 3 on both sides. No, add 4.
We want to add the 4x because we want to leave the y here. We want to get the x to the other side. So I'm adding 4x to both sides. And that gives me 3y. Okay, this cancels out, equals 4x plus 27. Can you see it? Okay. And what should I do then? What should I do with this now?
Divide all by 3.
Right. So I'm writing it over here because I think you're not going to see it on the bottom there. So that gives me y equals 4 over 3x, and 27 divided by 3 is 9. What is the slope here?
4 over 3.
Right. And what is my y-intercept?
9.
Okay. Now I compare them.
So it will be perpendicular.
Is it perpendicular? Be very careful.
Oh, no, because it has the same sign.
Right. It's not parallel because they're not both 3/4.
So would that... Go on, go on.
Yeah, and it's not parallel, it's not perpendicular. It's not the same line either.
So it will be neither.
Right.
Okay. Okay.
So you just have to put both of them in the y equals mx plus b form, and then you can judge. But remember, be very careful. I know this was a trick one, because right away when you see it upside down, you think, oh, they got to be perpendicular. But not only do they have to be upside down, they have to be, one has to be positive, one has to be negative.
How would I know if it's on the same line?
If it turned out, when you figured it out, that they looked exactly alike. In other words, this one came out to be 3/4 x plus 7, and this would have also had to come out to be 3/4 x plus 7. If they came out to be exactly the same when you put them in the y equals mx plus b form. And you would know they were parallel if the m's turned out to be the same. If this would have been also a 3/4 x, but they had different b's, then they're parallel lines. So when they have the same m's and the same b's, they're the same line. And when they have the same m's but different b's, they're parallel lines. Does that answer your question?
Yes. Thank you.
Okay. All right. I think I'm going to say have a nice weekend to everybody. And I'm going to leave now. I'm going to leave Melissa in charge. I know you're in good hands with her.
Professor, when you say that you're gonna send the email saying where are we in the class?
Well, since I'm extending the quiz due date until Sunday night, it'll be on Monday.
Okay.
But you could really judge yourself if you've done all the homework, because the only thing I have to judge you by is your results on Delta Math. Look on your Delta Math, but I'll give you an exact number and I'll tell you where I think you are. Thank you, Cheryl. Have a great weekend. Everybody stay healthy.
You too, Professor. Thank you.
I'm very grateful. I did get my COVID vaccines, and I'm hoping that will keep me and my husband safe. That's all we bring.
How do you feel?
Well, when after I had the second one, I was really sick. After all that, but I was only sick for 2 days, and then I was fine. So it was worth being sick for 2 days not to catch that horror.
Right. And your husband?
He didn't have any reaction.
Oh, that's
typical, good. Yeah.
So you go for one more, or it's just 2?
No, I had both of them. I had both of them.
I thought they said 3. It's only 2 now?
It was always only 2 as far as
it was?
Yeah, they're thinking about making a third, but they haven't said yet. And now there's this new one, the J&J, the Johnson one, that's only 1.
Oh, okay. Good.
So this was the first time I was really happy I was old.
Okay, good. Good, Professor. I'm happy for you.
Okay. All right. Be well. Have a great weekend. Bye-bye.
Okay, thank you. Bye.
Hey guys.